Do you know how silence sounds? Not the absence of noise, but the absence of something massive that was there just a second ago. Imagine standing on a beach, looking up at a bright full moon, watching the waves shimmer under that pale light. And then, blink, it's gone. Just black. The light on the water vanishes instantly. The sky is suddenly darker than you have ever seen it. And for about 1.3 seconds, gravity is still pulling on the ocean as if nothing happened. But then, the physics catch up. We often look at the moon as just a nightlight or a piece of rock that inspires poets. But it is actually the anchor keeping our planet from wobbling out of control. So, what happens if that anchor snaps? If the moon vanished right now, the first thing you would notice isn't the tides or the earthquakes. It's the confusion. Every animal that relies on moonlight for navigation, sea turtles, moths, dung beetles, would be instantly lost. The nocturnal ecosystem would crash hard. Predators that hunt by sight in the moonlight would starve, while prey animals might experience a population boom before the rest of the chaos sets in. But that biological panic is just the appetizer. The main course is the ocean. The tides would change immediately. We wouldn't lose tides completely because the sun also pulls on our oceans, but the sun is much further away. Without the moon, our tides would shrink to about 40% of what they are now. That sounds manageable, maybe even convenient for beach houses, right? Wrong. This sudden shift would move massive amounts of water across the globe instantly. Currents that drive our weather systems, like the Gulf Stream, rely on tidal mixing to function. If you stop that mixing, you stall the engine that regulates the Earth's temperature. We are talking about freezing winters in Europe and boiling heat elsewhere, essentially scrambling the climate map overnight. But let's talk about the weird stuff, the stuff we don't usually think about. The moon is slowly moving away from us. It drifts about 3.8 centimeters further out every year. It is a slow breakup, but eventually, billions of years from now, the moon will be too far away to stabilize us anyway. In a way, the moon disappearing is not just a hypothetical. It is a preview of Earth's very distant, very lonely future. Now back to the immediate chaos. Without the moon's gravity stabilizing us, Earth's axial tilt becomes unstable. Right now, we sit at a comfortable 23.5 degrees, which gives us our seasons. Without the moon, Mars is a good example of what happens. Mars has no large moon to stabilize it, so its axis wobbles wildly over millions of years, tipping over by as much as 60 degrees. If that happened here, the North Pole could end up where the equator is. We aren't talking about a bad winter. We are talking about ice sheets rushing toward the tropics over millennia. But in the short term, the wobble wouldn't happen overnight, but the Earth's rotation would change. The moon acts like a brake on Earth's spin. Without it, our days would eventually speed up. But let's look at a different scenario. What if the moon didn't just vanish, but shattered? We have seen this in sci-fi, but physically, if the moon were hit by something massive and broke apart, we wouldn't just lose a satellite. We would gain a ring system, a beautiful, deadly ring of debris around the equator. It would look spectacular, reflecting sunlight and making the nights much brighter than a full moon ever did. But chunks of that ring would rain down on us for centuries. It would be a slow-motion bombardment that could wipe out civilization just as effectively as a sudden disappearance. There is also a psychological impact we can't ignore. Think about how deeply the moon is embedded in our culture. Our calendars are based on it. The word month comes from moon. If it disappeared, we would lose our primary connection to the cosmos. We would be on a spaceship Earth that suddenly feels much more fragile. Let's go deeper into the biology. There are coral reefs that spawn only during specific phases of the moon. They rely on that light cycle to synchronize their reproduction. If the moon vanishes, these species don't just get confused. They fail to reproduce entirely. The collapse of coral reefs would trigger a domino effect up the food chain, affecting fish stocks and eventually the millions of humans who rely on seafood. It is amazing how a rock nearly 400,000 kilometers away dictates whether people eat dinner tonight. And here is something fascinating about the Earth's crust. The moon's gravity doesn't just pull on the water, it pulls on the rock too. The ground beneath your feet rises and falls about 30 centimeters, or a foot, every single day as the Earth rotates under the moon. It is called the Earth tide. If the moon vanishes, that stress is released instantly. The sudden relaxation of the Earth's crust would likely trigger massive earthquakes and volcanic eruptions across the globe. The planet would literally ring like a bell from the shock of the gravitational release. So you survive the climate shift and the ecosystem collapse, only to deal with a global tectonic snap. Let's consider a scenario that is less disaster movie and more cosmic detective. What if the moon disappeared because it was never there? Imagine an alternate Earth that evolved without a moon. Life likely would have started much later, or maybe not at all. Some theories suggest that the massive tides from the early, much closer moon were essential for washing the chemical building blocks of life from land into the oceans, acting as a primordial mixer. Without that violent mixing, the chemical soup might have just sat there, sterile. So in a very real sense, we might owe our existence to the moon not just stabilizing us, but shaking us up in the beginning. But wait, there is a silver lining. Maybe, without the moon, our nights would be darker. Darker than anything we have experienced in history. This would be a golden age for astronomy. No moonlight interference. We could see distant galaxies with the naked eye that are currently washed out. But that is a small consolation prize when you are dealing with superwinds. You see, because the moon slows Earth's rotation, if we had no moon from the start, Earth would spin much faster. Days might be only 6 to 8 hours long. With the planet spinning that fast, wind speeds would be horrific. We are talking about constant, scouring hurricanes. Evolution would have produced very different life forms. Low to the ground, sturdy, armored against the wind. No tall trees, no giraffes, maybe nothing walking on two legs. Now let's get speculative, really speculative. What if the moon didn't disappear, but was stolen? In the chaotic early solar system, planets traded moons or ejected them. It is dynamically possible for a rogue planet passing through the solar system to gravitationally capture a moon and drag it away. It is astronomically unlikely now, but the physics allows it. If a massive object passed close enough to Earth, it could fling the moon out of orbit. We would watch it drift away over weeks, getting smaller and smaller. The tides would slowly weaken. The panic would be a slow burn. We would have time to say goodbye. That might be worse than it just vanishing. Let's zoom back in to the night sky. Without the moon, we lose solar eclipses. That specific, perfect alignment where the moon just barely covers the sun, a cosmic coincidence that is rare in the universe, would be history. Future generations would only know about the ring of fire from digital archives. It makes you wonder what cosmic coincidences we are missing right now because we just happen to live in this specific era. Here is a strange thought. The moon protects us. It has taken a beating for us. Look at its surface. It is covered in craters. Some of those asteroids might have hit Earth if the moon wasn't in the way, acting as a gravitational shield or a literal physical blocker. Without our bodyguard, Earth becomes a slightly easier target. Over millions of years, the impact rate on Earth might increase. Not a shooting gallery, but the odds shift slightly against us. We also have to talk about the seasons again, but from a historical perspective. The stability of our climate allowed agriculture to develop. If the moon hadn't been there to keep the axis steady, and the climate had fluctuated wildly every few thousand years, humans might have remained hunter-gatherers forever, constantly chasing habitable zones, never settling down long enough to build cities or invent the internet. Civilization itself is, in part, a gift from the moon. There is a concept called the rare Earth hypothesis, which suggests that complex life is rare in the universe because you need a lot of specific conditions to go right. Having a large moon relative to the planet's size is one of those rare conditions. Most moons are tiny compared to their host planets. Ours is huge. It is basically a double planet system. If we find that life is indeed rare, the moon's disappearance in our hypothetical scenario underlines exactly why we are so lucky. We are walking a tightrope, and the moon is our balance pole. Let's pivot to the future again. I mentioned the moon is leaving us. One day, billions of years from now, the moon will be far enough that the Earth creates a tidal lock with it, meaning only one side of Earth will ever see the moon. But before that happens, the sun will expand into a red giant. The extra drag from the sun's atmosphere might actually cause the moon to spiral back inward. In the very, very end, the moon might not disappear by vanishing, but by crashing into us. A fiery reunion to end the system. But let's stay in the sudden disappearance scenario because it highlights how interconnected everything is. The magnetic field. Some scientists propose that the tidal forces from the moon help keep Earth's core liquid and churning. That churning creates our magnetic field, which protects us from solar radiation. If the moon vanishes and that internal heating stops or slows down, could our magnetic field weaken over time? If it did, our atmosphere would slowly be stripped away by the solar wind, just like what happened to Mars. We would eventually suffocate, unprotected from the sun's radiation. It is a long-term death sentence. Consider the psychological shift again. We look at the moon and see consistency. It changes phases, but it is always there. It is the oldest clock. If it vanishes, we lose that sense of permanence. It would be a collective trauma, a realization that nothing in the universe is guaranteed. The sky, which has been the one constant for every human who ever lived, would be broken. Also, space exploration. We use the moon as a stepping stone. We are planting bases there right now. If it is gone, we lose our practice ground for Mars. We lose the resources, the water ice in the craters, the helium-3 that we were hoping to use for future energy. Our gateway to the stars slams shut. We are stuck in low Earth orbit with nowhere close to go. What is truly wild is how much we ignore the moon until we imagine it gone. It is doing all this heavy lifting: gravity, climate, tides, biological rhythms, axis stability, and we mostly just glance at it and think, oh, nice full moon tonight. It is the ultimate silent partner. If you woke up tomorrow and the moon was gone, the first few days would be confusion and spectacular news coverage. The first few months would be ecological collapse. The first few years would be climate chaos. And the first few millennia would be a slow slide into an unstable, wobbling planet that might not support civilization as we know it. It forces us to ask, what else are we taking for granted? What other invisible forces are holding our reality together that, if plucked away, would cause the whole house of cards to collapse? We live in a delicate balance, a Goldilocks zone, not just of distance from the sun, but of gravity, rotation, and chemistry. The moon isn't just a rock, it is a key. And without the key, the engine of life on Earth might just stop running. Now look up at the sky tonight. Really look at it. It's still there. For now. But remember, in the cosmic scale of time, nothing lasts forever. Not even the ground beneath your feet, and certainly not the guardian in the sky. If you found this thought experiment terrifyingly beautiful, or if you just want to know what other cosmic disasters we are narrowly avoiding every day, you might want to see what happens when we look even further out. Because if you think the moon disappearing is bad, wait until you see what is lurking in the dark between the stars. That is a story for the next time.